Welcome to this feedback video of week 2. On the forum we still saw a lot of discussion about week 1, but most of the topics there were covered already by both the videos and the feedback video. So we're going to talk about the topics of week 2. And those were, for instance, cockpits and stability and control. One of the questions that I came across on the forum, which we didn't really discuss, was about the magnetic dip. And the magnetic dip is basically the effect that the magnetic field lines, when you are closer to the poles, become aimed more downward. And so there was some question what the effect of this is. Well, the main effect is that if you get closer to the poles, it becomes less accurate. But there's also another effect. And for this, I want to use this disc here, which we assume this is a compass which wants to point to the north. Now imagine that you are there in the north and this is pointing towards you, and we're flying with this compass, and now in effect what the compass really wants to do is wants to point really down, of course, but it can't do it because it's kept level. So what happens now when I accelerate is basically that it is tilted forward, the plane, so then it has the opportunity to point downwards a bit more, which means that this compass will turn a bit and it will seem as if I'm turning to the north when I accelerate. When I decelerate, the same thing happens, but then it seems that like I'm turning to the south. So one of the effects of magnetic dip on the northern hemisphere is that when you accelerate, it seems as if you turn a bit to the north, and when you decelerate, as if you turn a bit to the south. And there are more effects. If you have a turn, also your horizontal plane changes, and the effect of that the arrow that wants to point to the north also wants to point down can cause deviations in your heading during the turn or during acceleration and deceleration. All the signs, of course, change on the southern hemisphere, but this is the main effect. There were also some questions about neutral point and aerodynamic center, and for this I think it's better that we go inside when I can explain this. Let's go to the flight simulator, Simona. So one of the questions that you asked was, if the center of gravity has to move to the front for more stability, is it then a very good idea to have all the weight that you can have in the front as much as you can, because then you have better stability? Well, for the stability itself, this is true. It is indeed better to have the center of gravity completely in the front. But if you then also want to trim the aircraft, so you want to have an equilibrium of moments, so not just that the derivative is okay, but that the equilibrium itself is also okay, it means you need a large deflection of your horizontal tail surface to make sure that there's still an equilibrium of moments. And this high angle of attack or low angle of attack of at least an angle of attack which has a high absolute value, causes a lot of drag, and that's of course not what you want. And that's why in general you want your center of gravity close to the wing, so that in the ideal situation during the cruise, that your trim setting is close to 0, that your horizontal tail surface is close to angle of attack 0. If we look what this means in the graph, for instance, so if you have a center of gravity which is really moved to the front, then the CM alpha, which you see here, indeed will be very steep, but also the trim point will run away, and there's a risk there that you have a higher trim setting. You need to do something to make sure that the trim point is still in an acceptable range. So but for stability in itself, for the steepness of your CM alpha, it would indeed be a good thing if the center of gravity is up front, because if it's not, if it's behind the neutral point, then you will get a positive CM alpha which is unstable, because any change in angle of attack will also get a positive moment, which means it will run away from the trim point all the time. Another question which you asked is answered on the slide here, and that was basically, could you regard the neutral point as an aerodynamic center of the complete aircraft? Well, if you look at the definition of an aerodynamic center, it means that the moment does not change as function of the angle of attack. And indeed, for the neutral point, the CM alpha is equal to 0, so indeed the moment does not change as a function of the angle of attack. So indeed, when the center of gravity is in the neutral point, you could say that this is basically the aerodynamic center of the aircraft. But normally the neutral point has the meaning as the most aft position of the center of gravity that you can accept for stability. So those were the questions for this week. Keep up the good work. It's quite tough, the topic, the stability and control. Check out the videos a few times, check out the problems, and if necessary, replay this feedback video, and you should be okay. But it's normal that you find it hard, but work a bit with it, try the problems, and it will get easier. So keep up the good work and see you next time.